Okay, so here's two of the last theorems of the chapter. We're going to really focus on the top one up there, Isosceles triangle theorem. And down below is the converse of the isosceles triangle theorem. And if you remember, about maybe a month and a half, 2 months ago, converse is you flip the hypothesis and the conclusion around. And in some cases, the converse is true. In some cases, it's false. Here's a case where it's true. We're going to focus on the top one up there. It says in the isosceles triangle theorem, the two sides of a triangle are congruent. Then the angles opposite the sides are congruent. So here I have a picture of an isosceles triangle. Two sides are tick mark, which means they are congruent to each other. So the angles opposite those sides. So if you just go straight across from that angle and from that side and from this side, angle B would have to be congruent to angle C. While we're here, let's look at the converse. The converse says, again, the hypothesis and conclusion are flipped. If two angles of a triangle are congruent, then the sides opposite those are congruent. So the side that's opposite angle F would be this one right here. The side that's opposite angle E would be this one right there, and you could put tick marks there. So both things are true. Let's look at one example of a typical type of isosceles triangle question that you could be asked on a homework assignment or on our upcoming test. Okay, so right here is like ITT is the abbreviation, by the way, for isosceles triangle theorem. Here's a triangle GHG. Okay, I have these two sides tick mark, which makes it an isosceles triangle because two sides of that triangle are congruent. The isosceles triangle says that the angles opposite those sides, so that one and that one, also have to be congruent. So you could put arc marks here. Okay, then I could create an equation. 3x is equal to x plus 44. If I can get you to the point where you can write an equation, I know our success rate is going to be tremendously good because we can do algebraic equations. I've seen you do it. Minus x from both sides. I get 2x is equal to 44. Divide by 2, and I get x is equal to 22. Now, I noticed that Mr. Fiedler forgot to put directions up here about what the heck to find. So if we had to find x, that would be our answer. If we had to find these two angles, let's plug back in. 3 times 22 is equal to 66 degrees. And you know what? I'm going to plug it into the other one because they should be the same, right? So 22, and I'm looking at this right there, plus 44 is also equal to 66 degrees. And that makes me feel satisfied because I know they have to be the same in an isosceles triangle. All right, thanks for listening. Read over those two theorems a few times. There's a couple corollaries at the after these that said one of them says if it's an equilateral triangle, it's equiangular. And if it's equiangular triangle, then it's equilateral. And those come at the end. We did mention those before, but we will work on those a little bit as far as our review goes. Thanks for listening.